Ale on nevím, já ho mám zamutovat. No, počkej, ty oni to tady pořád ukazuje.
To podle mě tu ikonku mají nakreslenou blbě.
Aha, tak teď poznáš, jestli tam jde zvuk, nebo ne?
Teď mluvíš.
Jo, takže teď to mám vypnout, jo?
No.
Normálně v systému, jo. Počkej. Jo, tady vidím. Ty vole. A tu to nějak zapínat nemusím, jo? Jo. Takže potom, až začneme, tak akorát zapnu tady u sebe té prezentaci ten mikrofon, jo?
Jo. To je, kdyby zdechly ty baterky, tak si můžeš tam odmutovat ten mikrofon a
jo, a aha. Jo, ty vole, ještě víš, co jsem chtěl, ten. Ještě to ten šilák. Ne, to je jenom na to, na přepínání. Paráda, ty vole. Já si budu muset anglicky, jestli jsem Rumuní. Tak já si začnu. Můžu začít? Okay. Okay. So my name is Martin Pesch, and I work on the project which a couple of years ago started to introduce the microservices into our project. Originally, we were like a monolithic solution, and we decided to try the microservices. So in this presentation, I would like to share my experience. So there will be a lot of practical information from our project. So what I want to do in this presentation, like first I should mention what are the microservices, just like for people who don't know. So I would give just a quick definition what they are. I would mention what are the advantages and disadvantages. And obviously, as everything else, nothing is perfect. Microservices have a lot of issues. So big part of the presentation, I will concentrate how to face or how to solve the issues you could face when you start introducing the microservices. And at the end, I'll give you the guidance where you can go next, some study material where you can look, because this is just 1.5 hour presentation and microservices are a big topic. I can just barely scratch the surface, but my goal is to give you the idea what the microservices are, and especially the issues you can face when you start introducing them. So at the end, maybe you can, if you're thinking about microservices on your project, you would know what is it about and what you can face when you start using them. So before I say what the microservices are, first I say what's opposite the microservices. It's a monolithic application. It's the opposite of microservices. It's a term which I guess was invented by microservices people to say what is opposite to microservices. So what is the monolithic application? It's the application we used to all develop. It's the application which has its one solution is in one. It has a shared common logic, and it's one big shared source code which works together. And so this is like an example how you can imagine a monolithic application. Internally, the monolithic application, obviously, it can be split into the different layers, and it should be split into the different layers. It should introduce some architecture, like entire architecture or onion architecture. But what makes it different from microservices is that it's one block of deployment, and it has typically one central database. So when you deploy the solution, which can consist of many layers and many application or many APIs, you always take whole thing and deploy it at once. And all the parts of the monolithic application share the common database. So this is how monolithic application is defined when you want to talk about the microservices which are opposite to it. So obviously this architecture has a lot of advantages. They are much easier to develop, at least initially, than the microservices. But if they grow bigger, we might face some issues, as I will mention later on. They can be simple to deploy as well, because you're just deploying one piece, and sometimes it might be more complicated, but it's just one piece of the application you're deploying. And it's easier to do end-to-end testing since you deploy one piece. End-to-end testing is on that one piece, so it might be quite easy compared to microservices, as we see later on. It's easy to share common code, which sometimes doesn't have to be good practice, but sometimes it is good practice, and sometimes it's very convenient and save a lot of work because you have one source code base, you can share the common code. And this is a huge advantage. I should actually put this as a first. Like all parts of your application or of your monolithic application communicates in process, which is great because it's fast, like almost infinite fast. There are no errors, and you don't have to take any extra cares in handling the communication. And when you come to the microservices, we see that the situation is much more complicated. So that was all the advantages of the monolithic applications, but why we want to have a microservices? So there are probably some problems with the monolithic applications. When the project is small, these things don't apply, but if you work on bigger project for many years, soon you will face some problems with your application. The biggest problem is that your application, when it reaches certain size, it becomes too complex. And you would have dependencies in your application, and the complexity of the application and the dependencies in your application will be growing. And obviously, we can say that if the architecture of your application is right, you can keep the order in your architecture, and the complexity is manageable. But okay, in reality, sometimes or quite often when the project exceeds certain size, it will not happen. It also, there is a lot of things with your team as well. If everyone in your team is coding Guru, and these gurus also share the common solution or common idea how to create the solution, and if you have a time to do refactoring often, you can leave with the monolith for quite a long time. But typically on your application, you would have people of different level. You would have juniors, seniors. People would come and go, and if it's a many years application of certain size, typically your source code base become quite complex. And what will happen is that it starts to be quite hard to add new features because the code is too complex. You change one bit and you don't know where, like, what everything it will affect. The same with fixing bug. You might fix one bug, but because of the complicated dependencies, it might, surface in some problem somewhere else. So that's I guess the biggest problem. And another problem related to it that over certain size, suddenly no one understand the whole system. There would be different people who understand the different parts of the system, but there is no one who understand everything in the system, which is no good for future development as well. If you have new team members who come to the projects, it takes them a long time to get into that complex source code base, and it can be a long time before they become productive because they have to learn too much. Another problem you could face with a monolithic application is in certain circumstances it can be obstacle to continuous deployment, as we see with the microservice. When you change one bit, you just deploy one bit, but with monolith you have only one deployment unit. So even if you change little bit on the code, you have to do the deployment of the whole application. Related to the deployment problems are scaling problems, because with a monolithic application you have only one possibility how to scale. You can just create copy of whole application. There is like deploy the application in another copy or another replica, but that's all what you can do. Like you don't have many other variants. So if you imagine, for example, that part of your application receives a lot of traffic, and part of your application is doesn't have too much traffic, you will have to scale whole application, even these parts which don't receive any traffic, which is not very convenient. Or you some part of the application can be CPU extensive, another part of the application can be might need a lot of memory. So ideally you would just deploy that CPU intensive part to a virtual machine which has a lot of CPU power, and that memory, the memory application which consumes a lot of memory, you would just deploy somewhere else. But you cannot do it with monolith because you can scale only whole copy. And relate to this is also can be reliability, because typically everything runs in one big process. So if let's say in one part of the application there is a memory leak, it can bring like whole process down, and all of your application stops working. And uh, so obviously this is a big problem for production too, because it can be some part which is not important for the application, like which even if it goes wrong, the rest of the application should be unaffected. But if it's running in the same process, just one part goes wrong, everything goes wrong. And another thing is that you typically lock to the technology you choose at the beginning of the process of the project. Uh, when you started to develop the application many years ago, you stick to some framework, you stick to some tool, and as years go and new things are coming, you would like to use them, but it may be hard to rewrite all your source code base to use the new things you want to use. So very often can happen that you stuck to the technology you choose at the start because it would be too expensive to rewrite, and you cannot use all this new exciting stuff which is around. So I guess we have a microservices part. Maybe it's a good stop for pizza now before I go to the microservices. They here, so they don't get cold. Okay. Yeah.
Byla mi drzej. Z toho se stane, když já někdo drzej.
Jsi to škola? Jdeme to tak trochu tady. První tady pro no, okay.
Tak.
1, 2, 3, jde to? 1, 2, 3. Mělo by to být zaplý. Jo, počkej, ještě musím tady přehodit, že jo, vlastně, nebo ne?
No, já nevím, když dáš ten settings.
No. Mikrofon.
No. To by mohla být teď, dobrá. Zkus ještě tu poslední.
Raz, dva, tři. Jde to?
Jirka píše, že jo. Já jako tady nevidím ty čárečky, ale asi jo.
Dobrá. So, you know, the disadvantages of monolithic solution, like many companies face the issues I just mentioned. Let's name Netflix and Amazon, who came, I think it was these guys who started with microservices, or at least embraced the microservices in the big way. And I think you don't have to be on the project of size of Netflix or Amazon to, you know, to try microservices as well. I think it can benefit even the small project. Obviously, our project is not Netflix or Amazon, but I think it benefits us. So what are the microservices? There is many definition of the microservices. I think there is no single definition or no single definition on which community agrees. I will just stick to the very simple one, that microservice is basically a mini application which has its own UI or API. It has its own business logic, and it has its own database. The own is very important. Like the microservice doesn't share database with anyone else, or doesn't share the business logic with anyone else. And microservice is deployed separately. Here you have like a different definition from Martin Fowler, but it's pretty similar. What is it? What is the one I mentioned? So, you know, we know this definition. So I show some picture of some monolithic application. So I will take this monolithic application and I break it into small pieces, where in every piece I put the different classes from the project I had. I break my database, and like, you know, now every microservice owns its own data, is in charge of it. So what advantages I will get by doing this? But obviously, as you could see, I broke that big monolith I had into some small pieces, which are much more manageable. Like now, there could be actually one person who is understanding one microservice and can be in charge of it. You enable independent development. Like now, like you could have a different teams which develop different microservices, and they don't need necessary knowledge about another microservices. Obviously, they would need the knowledge about the interface the other microservices implements if they're going to use this microservice, but they might not need to know anything about because like microservice is basically independent API or independent application. You can actually choose a different technology for each microservice. I don't know if it's a good idea or no. It depends obviously on the project, on the team. If you have just .NET developers, you could probably use the same technology everywhere. But if you are on some big project which has a different teams, which are experienced in different technology, you can use the different technologies for different microservices. Why not? Depends on your project needs. It might become easier testing the changes done internally within the microservice, because now you have like smaller manageable chunk of functionality, which has very well-defined interface. So if you do some change in internal working of that microservice, it's easier to test because you just test that smaller chunk of functionality. You can do independent deployment. So like, you know, as I mentioned the scaling before, now you have much more options how you can scale your application. So you can
the microservices which receive a lot of traffic, you can scale in many copies, and the microservices which don't have any traffic, they might just need 1 copy or 2 copies for backup. And so this is all good, right? So obviously there is wrong side to it as well. I will start with the communication. So obviously the microservices are not completely isolated islands, because they need typically data from another microservice. So typically what you do is that you create the API and you expose the data you manage in your microservice through that API. And if some microservice need data from another microservice, it's just call the API to get it. So it seems very logical, and this is probably what you would do first if you don't learn beforehand what problems it can bring. So what is the problem with this kind of approach? There is actually a guy from Sun Microsystem who wrote this little article on Wikipedia called Fallacies of Distributed Computing, because it was not about the microservices, it's called old article, but he noticed that a lot of people who come to distributed computing system, and distributed computing is pretty much in topology terms the same thing like microservices. He noticed that people who are new to distributed computing, they come with some false beliefs of what distributed computing is. And so he wrote these about 8 fallacies of distributing computing. Fallacy is false belief. So, and they apply to most common mistake people do when they come to the microservice and they don't have experience with microservice. So the first fallacy or false belief is that the network is reliable. The network is not reliable. You get packages lost. So the communication between the microservices is not 100% reliable, like you had when you were working when you had the in-process communication, right? Another fallacy is that latency is 0. That it takes neglectable time to call another service, but it's not. If the latency might be one call might be quite small, but if you have many calls, you can see it very soon. Another false belief is that the bandwidth is infinite. It's not. Even if you have a very performant network with a big bandwidth, if your microservices gets too chatty, the bandwidth can get used up, and the whole system can become unresponsive. And another important thing is that the fallacy is that the network is secure. It can be true in some cases, but now imagine that you have a microservices communicating over different networks, and then you have to take care of the security. You have to take care of the fact that you want to authorize who can access your microservice and who cannot, right? There is more fallacies, but these are the most important one. So microservices are definitely no silver bullet to the development, and when you go to the microservices, you will face a lot of issues as well, which I mentioned now. So I already mentioned the complexity of distributed system communication. You don't have in-process communication anymore, which was reliable and fast. Now you have unreliable communication, and you have to handle failures in that communication because it's not reliable, and you have to also handle the slow responses for that communication. There is actually quite interesting. Presentation from one conference. I think it's called Microservices Disasters, and it's about some guy who was invited as a consultant to the microservices project, which went wrong. And what happened was that these guys decided to go to microservices. They broke their big monolithic application into hundreds of pieces, and they just did simple that API calls everywhere. And when they first started the system, nothing happened. They were waiting, nothing happened. Like timeouts were expiring, so they set all the timeouts to maximum. and it took them, I think, 12 minutes before the first page of the web application display. And it was because they had these false beliefs about the network communication. And when they analyze how many calls they need to assemble the first web page, they get to something like 200 web API calls. So obviously that was very bad design, because you cannot have network enough reliable and enough fast to handle such a chatty interfaces and to display the page in that. I put the link of the presentation. It's really interesting to see at the end, so you can watch it. Another big problem which might not be apparent at the beginning, is that because every microservice has its own data, you will have to take care of data consistency. If you have one central database, you don't care too much because you use the database transaction. So database is your friend, which will take care of it. And it's so easy to use that you forget that you have to keep the data consistency if you don't have a database. If you need to handle some business transaction, you have to do some, your explicit handling, how to do the transaction, because your data are not in a single database anymore. So that brings, in some scenarios, that can bring quite big complexity to microservices architecture. It can be harder to deploy, not service by service, because the services are small, but like to deploy all services. For example, you need to set up a new environment. It's obviously much harder than setting up the environment for monolith application, because you have many services, you have many moving pieces which you have to deploy and coordinate. And I mentioned that it might be easy to do the testing of a change within one microservices. That's true. But on the other hand, if you need to do end-to-end testing, meaning like the testing of some call which goes through many microservices, it's much harder to do now, because you have to ensure that all microservices which participate in that end-to-end test are running and are healthy. So in the rest of the presentation, I will show you how to handle some of these issues I mentioned here. First important thing when you're thinking about the microservices or you start with the microservices is the microservices design, how you split your solution, and you have to determine what microservices, the number of the microservices you have, and how big they're supposed to be. There is actually not a single definition of what is the right size of the microservice. There is no explicit metric or. Well, I mean, yeah, there's some discussion, but basically, like the community as a whole doesn't agree on what's the right size for the microservice, and I think the majority wouldn't agree that you can have some explicit metric like number of the source code lines or whatever to say what is the right size. So I just give you like few ideas how you can determine the size of your microservice, or patterns you could use when you're thinking how to split your microservices. One well-known pattern you should use in your class design in a monolithical application is single responsibility principle, meaning that the class in this case microservice should do just one thing and do it right. So related to it is that the microservice should have a small number of operation and functionalities, and these operation and functionalities should be quite interrelated. And a very important thing is that the microservice should have well-defined interface, which should be quite stable and shouldn't have many methods. There is actually one discipline many people in microservices world embrace when they want to design their microservices, and this is domain-driven design. By domain-driven design has originally nothing to do with the microservices. Domain-driven design is basically about you know, when you solve some complex business issues, it's about how you model the business processes and business domain in some abstract model, and then how you implement the code which reflects the model. And during the modeling and implementing, you keep both things in sync. And in domain-driven design, there is this principle which is called bounded context. Bounded context is basically like you know, part of the domain which is quite self-contained, which has its own data. It can have its own vocabulary. It can be, for example, accountancy module, where just accountancy people know what it is about, and you know, it has its own well-defined interface. It speaks to other bounded contexts through some well-defined interface, and it has its own data. And in this domain-driven design, it's whole set of practices, and you know, it's quite a complex thing. I try to just read a bit of it, and I have to admit I didn't get too much into it, but that's one way you might go, or you might consider when you want to learn more about how to split your microservices in the best way. It's like to do one bounded context, one microservice is one of the very frequent recommendation which you can use when you want to design your microservices. So another important thing is the communication between the microservices. I think actually from the experience on our project that these are the most important things which will determine if your microservices succeed. This is to decide how you split your microservices and do it right. And then the other very important things, how your microservices will communicate. The options you have, there are many more options than just web API calls. I just wanted to show a little demonstration what you can do about the communication between the microservices to avoid direct web API calls. I created just a simple example, but that example is actually a bit from our project. So it's a real-world example. It's just a little part of the system. In the real system, you would have much more microservices, but just for illustration of some principles, I will just use the part of the system. So imagine that you have a solution. You are some financial institution which implements a payment gateway. That payment gateway can be used by airline websites or by e-shops, or you know, the train companies to handle the payments in the website. So the payment gateway can be some plugin, like you know, the external your clients put into their website to handle the payments. So this is the first microservice which would reside on many clients' website, and which would handle the customer when he get the ticket or buy the goods. He would go through the payments on that payment gateway. So obviously, you know, you need to manage somehow your clients which use your payment gateway. You need to keep contact for them because you're going to invoice them. You know, you want to get paid from the clients you have for using the payment gateway. So you need to manage the configuration. Obviously, you would have to also secure your payment gateway. So somewhere you need to keep the client credentials, the secrets. So that for this you would have another application called, I call it client configuration, which will do this. Basically, when new client comes, like new airline saying, look, we want to use your payment gateway. So you would have an administrator who would go into the client configuration microservice, which is mini application where you would create, you know, you would manage your clients. And so obviously for payment gateway, it will be the customers, many thousand customers coming to pay. For your client configuration, it will be your internal company administrator. From time to time, when new client comes, will do some changes in there. Obviously, when the gateway, when the payment is finished, because you are a financial institution and you provide these payments, you need to know that payment was completed, and you have to do something in your accountancy system. It's not important what it is. So that's another example of the microservice. And the last thing for my example is just the little microservice, which is again a real example we have in our project. Imagine when the customer fills something in the payment gateway, he has to fill his address as well, and he has to type the postcode. So just to make it for the user easier, you provide autocomplete. So when he types the postcode, you offer him, based on some lookup, you offer him like IDAS, what is the city, the autocomplete for this. So that's another sample of the microservice for just for the illustration I created here, right? So that's just the example. And now in initial solution, I will do just so far what we learned, just simple web API calls, right? So now I can illustrate some problems which can happen with the web API calls. Let's start with this post lookup, right? This post lookup actually, and this is our example in our project as well, it actually uses some external web service, which I call here world postcodes, where we actually get our postcodes from. And imagine that external web service is not 100% reliable. It has quite frequently, it has outages, it doesn't work all the time. So because of that, you create a cache in your microservice. So once you get some postcode, you keep it locally for, let's say, 3 days. And if anyone asks for the same postcode, you would return it from the cache, right?
Are you sure that the name is correct? It shouldn't be zip cache?
Well, zip is American, postcode is British, so it depends where your culture.
I'm sure that in British it's not PSC.
Well, this is like a postcode, right? So.
Oh, okay.
Even if you have a cache here, like imagine that the customer comes and enters the postcode, which is not in the cache, and so it still needs to contact the external service, which is not very reliable. And another characteristic of this communication is that this is actually no crucial part of the system. You know, if the postcode don't work, you just should not provide the autocomplete. Okay, the customer will have to type the city manually, but it's not a big deal here. And so if you don't do anything, what can easily happen is that this service is not running. So the customer types the postcode. You would call that API. This calls another API because this is not running. And it doesn't give 500. It's just not responding. So you would have here hanging that API call. Now another customer comes, and you would have another web API call, and then you have many web API calls waiting for completion. And at some point, what will happen is that the thread pool here and the thread pool here gets exhausted, and your whole application is dead. Your whole payment gateway is dead, and any customer who comes cannot pay because your thread pool is exhausted, right? And you lose the business, you lose the money. So what can you do about this? Important thing is that that autocomplete functionality is not important. So what you can do is you would return some response saying, "Oh, I'm not available," and your payment gateway would just not provide the autocomplete function. The customer will not even notice that something goes wrong, right? But how can you avoid the blocking the calls? There are a couple of patterns you can apply for that API calls. One pattern is called the retry pattern, and one call is called the circuit breaker pattern. They quite different patterns, but they work together to provide functionality how to handle this type of the situation. Retry pattern is pattern which you can use for something which is called transient errors. Transient error is error which is typical in the web APIs, and that's the type of the error which is just you call some service. At the moment, it's a bit busy, or it's down, so it will not work. But it doesn't work for a split of seconds. So if you call 3 seconds later, your call can succeed. So this is typical transient error situation. So what will retry pattern? What will do is that it will call external service with some small timeout, and if it doesn't succeed, it will wait, let's say 3 seconds, and try it again, right? And if it was transient error on a second attempt or maybe on third attempt, it will get through, right? So the guy here, the customer, is waiting a bit, but at some point he would get answer. Like you wouldn't get any answer if you don't have any retry button because it would fail on the first time. But what happened is if the word postcode or this service is done for a long time, you would still get to the same problem. Like, you know, you would create many web API calls, even worse, like these web API calls would be automatically retried. So at some point you are in the same situation, you will exhaust your thread pool and your service will become unresponsive. So that's why there is a circuit breaker pattern. And circuit breaker pattern is pattern which you configure that after a certain number of the rep requests, if they don't succeed, they will return immediately the error for any other call. So like, you know, what that means that, let's say I would have a retry pattern set to number 2 and circuit breaker set to number 3. So there would be customer who will come, another customer who will come, and the circuit breaker will count unsuccessful calls. And if it counts 3 unsuccessful calls, it will disconnect. That's why it's called the circuit breaker. It will break the circuit, and it will not call this service anymore. Yeah, it will return the error immediately, and it stays closed, or sorry, it stays open, meaning that the circuit is open. It's from the electricity switch terminology. So it will open some configurable time, let's say 5 minutes. And after 5 minutes, it will let a couple of web APIs go through to see if they succeed or not. And if they succeed, it will close. So meaning that the web API calls will succeed again. So, you know, by putting the circuit breaker in, you can prevent that thread pool exhaustion or whatever, like, you know, in your website quite easily. That circuit breaker actually, you know, it can be done here. It might be more convenient to be placed here, or the best it should be placed in both places. It's actually good practice to put the retry circuit breaker into every web API call, and Netflix, for example, is doing it as one of the practice they have in the microservice solution, right? So by retry circuit breaker, we sort out the communication with this microservice. If you have any questions, just ask me, just stop and talk to me, and I can stop and explain more. Another type of the communication you can have is, let's illustrate on accountancy system, right? Accountancy, let's imagine that accountancy system is microservice, again, which it's microservice talking to some old bank system, which can be quite slow and unresponsive. And again, like what can happen is that, like, you know, the payment finish, and you need to call accountancy to get this operation accounted for, to you know, to have it in internal ledger entered. And you can face the same problem like with the postcode. And when you think about the customer, he doesn't care that you know, that the bank internally has to put the payment complete into the accountancy. It's for a customer, this is not important. The customer, from his point of view, he finished the payment and he doesn't care if it gets into the accountancy or not. So this type of the communication can be converted to a type of communication called fire and forgot, meaning that I here is this service, I'm not actually interested in a result of the accountancy. I just want to let accountancy know that the payment was completed in a reliable way, but I don't care about the result. I don't care what accountancy with this done with it. And for this type of the communication, it's much better not to use web API calls, but to use the queues, or more generally service bus. I get to the difference a bit later on. So queue or service bus works in the way that it's a service, it's a communication service which has its own internal storage. And in this scenario, the payment gateway, when it completes, the only thing which it does is it will publish payment completed even on that service bus, and it returns immediately. So the payment gateway is responsive because to publish even to the service bus, it's reliable and it's fast. And at some point, it doesn't matter when, this guy is subscribed to the service bus. So when he has a time, he will take even by even and process it into the accountancy, right? So this is how we can sort out this type of the communication and replace the API call with much more efficient call. Another interesting communication is here between the payment gateway and the client configuration, right? Like, imagine that the client gets changed very infrequently, like, maybe that the financial institution has new clients every couple of days. So every couple of days, the administrator comes and change something in configuration. So, like, the data here in the client configuration are quite stable and don't change very often. But the payment gateway uses this configuration very frequently. Like, this configuration is needed by payment gateway to set up different options for different clients on their websites. So what would happen here if you use the web API calls, that though these data doesn't change very frequently, you would have a very chatty interface going to the client configuration, which again can cause delays, and which again, in a situation when the client configuration is not responsive, can make your payment gateway unresponsive and you lose the business again. So what you can do about this? What you can do, and what is very common pattern in microservices world, is that you will have own copy of the data from another microservice, and you use locally that own copy. And that copy of the data will get updated in asynchronous way. That way of asynchronously updating your local copy of your data is so-called integration event pattern. So what happens here is that this client configuration has many tables which contains various information about the client, and payment gateway is interested in part of the data, so it will create its own copy of the data. It can be completely different tables. It can be just projection of what the client configuration has, and you would use the service bus to update the local copy, right? So in this type of the communication, like when administrator change something on client configuration, update some data, or introduce new client, after your internal data is updated, you will publish the event. There is a change in the configuration, and you will pass all the data in that event. And this guy is subscribed and listening for this event, and when that event comes, it will read the data and it will update its own copy, right?
Isn't then the bus service single point of failure when you build it like that?
It is single point of failure. Yeah, but service bus is is considered as quite a reliable solution. Like when you would use the service bus, typically you would use the third party. I will get to it. You would use the third party implementation. We, for example, use the Azure Service Bus. And you can configure service bus to have many instances which supply each other. These instances can be in different data centers around the world. So you can make this type of the communication very robust. So, but yeah, it's true. It's a single point of the failure. But the chances that the service bus fails, it's much lower than the web API call will fail. Just the simple web API call. So, I like just on this simple example, I shown you how you could change the communication between your microservices to make payment gateway quite robust. Because now, even if all the services, all the free services are down, your payment gateway will still work. and it can be quite fast as well, because like most of the most of the requests coming from the customers will be handled locally and will not be delayed by making calls to another services. Obviously, it's much more work. Yeah, you have to implement publishing the event, subscribing to the event, and you have to keep your own. You have to take. You have to keep the copy of the data which is sourced somewhere else. So, just if I summarize what we learned about the communication in the microservices, the communication can be synchronous, which is typically web API call, but you might use the platform which can provide some alternative way, some other remote procedure calls. Synchronous web API might be necessary in a situation when you need an immediate response, when you need to wait for the response and you need to do something with the response. If you use the synchronous web API calls, use the retry circuit breaker patterns at least. And you don't have to implement these patterns manually. For example, in ASP.NET Core or ASP.NET World, you can use the third-party library called Poly, which will, in a very simple way, help you to implement these patterns on every web API call.
I think that they introduced it into the Microsoft Word, so it's not no longer third-party, I guess.
Sorry, it's what?
I don't think it's third-party. It's like Microsoft.
Oh, Microsoft. Okay, maybe. Yeah, I know Microsoft.
Third party. Now it's like it's
okay. Yeah, it might be because Microsoft actually use it. If you use the Azure services and you use the client SDK, that client SDK internally use the Poly to make calls to the API of Azure as well. If you use the synchronous web API, it's very useful to use Open API standard. Open API is basically a standard of documenting of your web API interfaces, and obviously, you get the documentation of Open API, but the documentation is it's a JSON standard, so it's machine readable. So apart from documentation of your API, which is important for the team who wants to use your services, you can also get option that you can use some other tools, and you can generate a client code. So, like how it normally works, for example, in .NET World, is that we use Swagger, which is a third-party plugin into the ASP.NET Core, and that Swagger will, or is it already part of Microsoft as well? I don't know. But anyway, what will happen in the ASP.NET Core application that it's just like a simple plugin into your Hive, and it will read your controllers and it will generate Open API specification for you. And then you can use, so that's on the server side, that's on the side which implements the API. And then on the client side, meaning the microservices which needs to call your API, you can use Autorest or NSWAG Studio, that's just a sample of another call, which will read that Open API specification and will generate a proxy for you. So, it saves you a lot of work, and also it implements good practices in making that API calls as well. Yeah, and Open API is not .NET; it's a industry-wide standard. So these tools I mentioned, they for .NET World, but you will find definitely equivalent in other technologies as well. When you use the synchronous API calls, you have to be aware of number of the hops between the services. You don't want to have long chains. I told you about this 200 long chain and then resulting 10 minutes waiting for the first page to load. So you have to be careful about when a customer or like external service call your APIs, how many web APIs, other inside web APIs are generated by this. Somewhere I read that the general recommendation is to have 2 hops maximum, like 2 web API calls maximum. I think it's quite strict in our solution. We have some cases where we have 3, but it's quite hard to achieve that small number. So if you don't have to use the synchronous communication, You should use the asynchronous communication, as I shown in a previous example. That's very convenient for fire and forget scenario when you don't care about the result, like it was with that accountancy service. Or you can use it to implement the integration event. That was when the situation I shown before, where you have the copy of the data from another microservice, and you update this copy asynchronously when the other service published the event that something changed. Yeah, you should prefer this communication where it's possible, because it, as I show, makes your microservices ecosystem much more robust and performant. What the problem with this asynchronous, especially when you use the integration event, is to keep your data consistent, because you keep the local copy of some data, which is changed from time to time in the source. So how you keep that source of the data and your copy in sync, that can be quite complex. There are different ways how you can do that. In our project, we use something called Outbox pattern, but there is quite a lot of things to say about that, which will not fit here. So if you're interested, I can make some other time some different presentation where I just would talk about the problems of the asynchronous communication. And yeah, obviously, when you use the asynchronous communication, you don't want to implement it on your own. Use something from third party. Azure Queues or Azure Service Bus. That's the managed service. So that means that you use you configure the service on Azure Cloud Portal. You don't install it yourself, or you can install, or you can use some third party like RabbitMQ or Kafka for asynchronous implementation. Yeah, and as Miracek said, it's a single point of failure, so you have to be very careful about how you use it.
What's your percentage in your project between synchronous and asynchronous operations? Like it's 90 to 10, 50-50, 40-60? Just guess.
Well, we use a lot of integration events. Well, I would say 50-50 at the moment.
Yeah, because my opinion is asynchronous. Yeah, it's probably in many cases it's better, but it's add the complexity to the system. My opinion, just.
It adds. I mean, that's like, especially with integration system, when you have to take care of data consistency, it adds quite a lot of complexity. That's
my point.
Yeah.
And you need probably some versioning of it and.
Yeah, but versioning you need it, but API as well. That's.
Yeah, but in one moment you start just call the new version, and that's all. Now here you can be it's smart. You're right.
Yeah. I mean, yeah, that's a good point. Like, it's very important when you do your microservices design to do it right and to make your interfaces as simple and as stable as possible. And when it comes to the changing the event form shape or like that API DTO shape, you have two options. Like if you make a simple change, we just add something. Let's say you add a new property to the DTO which is used in the API, or you just add a new property in integration event. Then your client implementation can be implemented in the way that it's resilient to these changes. So if you're not interested in edit property, you don't have to do anything, which is what we do. So for this type of updates, you just change your implementation if you're interested in that property. But obviously, if you need to do some, you need to change property type, or you need to switch one property for another property, then it's a problem. Then probably you would have to stick to some versioning mechanism, or you would have to think how you deploy your application when this change will happen. So that was two big things when you come to the microservices: how you design your microservices and how you design the communication between them. That's the most important thing, I think, in the microservices if you want your microservices architecture to succeed. But there is more problems you would face with your microservices. Your security, you have to take care of security of your microservices. Because your microservices now communicate on the network, potentially you would have much bigger attack surface for much more places where the hackers can enter your system, because they cannot get into the in-process communication, but eventually they can get into the network communication. So typically in microservices solution, you have to handle security in various scenarios. Like one scenario is that for single page application or for mobile clients talking to the back end, you need to secure that communication. Another type of the communication you have to secure is service to service. And it makes also sense, like, you always have to think as well how your services communicate, if it's just the internal network or internet. Like, obviously, if you have a single page application, you always talk over the internet with your backend. So, these are the various scenarios which have very different security requirements. So how you handle these? I would say from our experience that OpenID Connect is your best friend to do this. OpenID Connect is a standard, it's a security standard. And OpenID Connect, it's actually a set of scenarios or set of standards how you can handle all these scenarios I mentioned here. So it's based on All-Out 2, but it extends it for other scenarios. So it covers machine-to-machine, like service-to-service communication, but it also handles the single-page application or MVC, like server-side web application. All these scenarios, which has very different security requirements, are covered by OpenID Connect. So if you want to be sure that you secure security is difficult, and no one likes the security, like to get involved with security, and you definitely don't want to implement your own security. So the best way is to stick to some standard which was done and thought through by someone else. So I would say that OpenID Connect is a standard in securing distributed systems these days. And if you use OpenID Connect scenarios in your microservices world, then you can use different software to handle it. You don't have to implement that. OpenID Connect is a standard, so obviously you have to implement this standard. You need to provide some implementation to this standard, but because it's a standard, there is a lot of third-party systems you can use, and you don't have to implement it on your own. Like in our case, we make a proof of concept, or we tested identity server, and identity server is fine, but it's very versatile. It's a plugin you can add to your ASP.NET Core application, and you can create. It will implement some OpenID Connect, but you have to do a lot of your coding. But actually, later on, we found out that what we need in our world was just to handle some standard scenarios. We didn't need some extra customization, so we found out that we can use the Azure Active Directory as a service. And Azure Active Directory, it does implement OpenID Connect. So at the moment, we didn't do too much implementation about the security in microservice. We just delegate the security to Azure Active Directory. And Azure Active Directory is taking care of machine-to-machine security for SPA to backend security as well. Yeah, of course, if you communicate over internet, you should always use HTTPS. And another help you can get is if you use some hosting platform for your microservices or some orchestrator, because they quite often they manage your security to a certain extent as well. I will get to it later on, for example, with Kubernetes, how it handles the security for you. So a lot of things, for example, service to service, if it's just the internal communication, and use the Kubernetes can take care of that. So another area or another headache with microservices, if you want, can be deployment, because now instead of one application you deploy, you have many applications, you have many moving pieces you have to deploy. So it's quite important to use some solution which will help you to manage the deployment, which will does a lot of dirty work for you. When we started with microservices, and we just have a couple of microservices, we actually for quite some time we were able to use just Azure Web Apps, which is the managed hosting environment implemented in Microsoft Azure for hosting small web APIs or web jobs. Web jobs is background task. And that was fine for a small number of services and for initial deployment, like from initial proof of concept. But it's not really a platform for a big number of the microservices. You would need more to get from the platform than you get from Azure Web Apps. So that's where the orchestrators come to the place. Orchestrator is something which will provide functionality for you to handle high number of the services, will handle things like service discovery. Service discovery is how you know what URL have to call if you want to call this web API, which will handle updates for you, health monitoring, and other things. And like you know, there are like a third-party orchestrators. The most common one these days is Kubernetes. I will say something about Kubernetes in the next slide. But there are some other orchestrator platforms. Docker implemented their own, called Swarm. But I think Docker is now switching to Kubernetes as well. Like if you install Kubernetes, if you install Docker on your desktop in Edge Edition, you will get the Kubernetes inside your Docker infrastructure as well. And another well-known orchestrator is Service Fabric. That's the Microsoft orchestrator. By the way, Azure is running on Service Fabric. So if you use some managed service from Azure, like for example Web App or SQL Azure or whatever internally, it will use the Service Fabric. We were evaluating actually for our needs. We were evaluating Kubernetes and Service Fabric. We decided to go for Kubernetes. I will mention a bit more on the next slide. But before I do that, what another important thing when you come to microservices deployment, because it's quite a complicated thing, it's to embrace something called DevOps. I guess you know what DevOps is. DevOps is basically like a new trend that you don't have two very independent teams, development and operation teams, but you have one team which takes care of everything, or you can have people who takes care of development and operations, but they close, they cooperate with each other very closely. So it's opposite of to what it was before, that you have a development team which develops some software and then they throw it to the operations team and don't care, and the operation teams have a hard time to make it working. And when something goes wrong, it takes a long time or some heavy process to propagate the results of that back to the development team. So DevOps is set of practices where you connect development and operations together in order to achieve like a very quick lifecycle development. One of the good practices of which is embraced by DevOps is continuous integration and continuous deployment. Continuous integration is you make a change on your source, you commit to your source control, and it will automatically trigger the build. And if the build succeeds, it will go to the continuous deployment part, and continuous deployment means that that build is immediately deployed to some test environment, typically. And a lot of these practices you can obviously implement yourself using different parts, different platforms, or you can, different tools, or you can use some managed service which will provide templates and the ways how to set up new processes very quickly. Again, because we are .NET people and we use Azure, we use the offering from Azure which is called Azure DevOps. And in Azure DevOps, yeah, it's an environment where you can which will take care of pretty much of all your stages of your life, of your software life development cycle. Yeah, it will help you with the requirements. It will provide a source control. It will provide continuous integration, continuous deployment, and bug reportings, and so on. So I promised to say something about the Kubernetes, which is one of the orchestrators. Kubernetes is what we use in our project as well. So what is Kubernetes? Kubernetes it's a software which was developed originally by Google for its internal needs, but then Google make it open source, and now it's open source, and there are many contributors to Kubernetes. Microsoft contributes to Kubernetes quite a lot as well. And so what is Kubernetes? Kubernetes is software you deploy on several virtual machines. I say it in a very easy way. And what that software will do is that from one virtual machine, it will create something called master node, which is controlling node, which will control whole cluster. And then, a couple of nodes which will run your services. And what is the most important principle of Kubernetes? In Kubernetes, the most important principle is that you define your deployment in declarative way, meaning that in a deployment file, you say how many replicas of certain microservice you want to run. Like this is example of deployment from one microservice. I say, okay, this microservice is called checkout web deployment. That deployment, I want to have 4 replicas because it's quite, it enjoys some quite a bit of traffic, so I want to run it always in 4 replicas. Now Kubernetes, I forgot to say, Kubernetes works with Docker images, so you have to say which Docker image contains your microservice, and you can add some other configuration options like environment variable or so on. So you say declaratively what you want from Kubernetes. I'm telling Kubernetes, okay, please create 4 replicas of this microservice, which is implemented in this image, and you throw it at Kubernetes, and Kubernetes will read the specification and will do everything to keep this state and maintain this state. So it will typically, what will happen when you throw it there, it will download the images from the registry you specify here, and it will create 4 replicas. It will spread them to different nodes using some logic, depending on how the node is busy with other microservices. And it's not just that it will also monitor the health of the services and health of the nodes. And if service dies or node dies because of some hardware problem or whatever, it will actually, it will catch that event, and it will redeploy your service to different node. So it will always try to keep your desire, which you put in the specification, like implemented. So that was very briefly what is the main reason of the Kubernetes and why you might want to consider it for your microservices, because it can make life of deploying your microservices and monitoring them much more easy for you than if you have to do it manually. Yeah, apart from the stuff I mentioned, there are many other considerations when it comes to microservices. At least from our experience, what made our life much easier was the decision to go to the cloud. A lot of things we don't have to install. We just use managed service offered by the cloud. So, for example, instead of procuring 6 virtual machines and taking care of installing Kubernetes software there, we use the managed service from Azure called Azure Kubernetes Service, where in a few steps we just say how many nodes we want to have in our cluster, and Azure will create it for us. We use many other services as well, not just like, you just don't use the hosting service. You might want to, your microservices might have some data storage needs. So they might need a SQL database, they might need a document database or whatever. So for that, it's much easier, at least in our experience, to use the managed service from some cloud providers than to install it ourselves. So these are all the services you use from Azure, and which makes our life much easier than to install everything manually on some on-premises architecture. Key Vault is quite useful service to handle your secrets in your solution, the connection strings and things like that. And apart from SQL Server, which in cloud is called Azure SQL, we use other data storage options. We use blob and queues, which are simple data storages, which are much cheaper than Azure SQL, and for certain scenarios, much more performant as well. Active Directory I already mentioned for handling our security. What's great with microservices is that it will make reusing the open source much more easier for you. And typically it's easy to reuse the do-not-get packages, but you can do it in monolith as well. But if you go to the microservices, certain standard components can already exist as a Docker image, and you don't have to do anything about the implementation. Like one standard component which is used in microservices code is so-called API gateway. API gateway is a service. If you have let's say a single-page application, some JavaScript application running in user browser, and it needs to talk to the backend to different services, but these services are provided by different microservices. You don't want to call each microservice individually, because it would be quite complicated for client developers to know the microservices URLs. So use something called API gateway, which is just one component which will call different microservices on your behalf. And API gateway can also take care of it can take care, for example, of security, that it can be HTTPS endpoint. So your microservices can be on internal network and don't have to implement HTTPS, because they will be accessed only from like a confident API gateway, and the API gateway would be the endpoint for SSL. So this API gateway, you can implement as another microservice and do some coding, but you can use the API gateway which was already done by someone else, and you can use it as an image, and you just specify it in Kubernetes deployment, and you have it. So yeah, they're using, there's many, let's say the API gateway is just one example, but there's many other services you can reuse. Another practice we found quite important in our project is to document your architecture, the way you split your microservices and how they communicate. We found that, after your microservices reach a certain number, you want to keep track of how they were split and how they communicate. When you're adding new service, you don't want to create that mess I shown with the web API calls. So, I think it's quite important in using some diagramming tool to document your architecture and keep it up to date. We use old-fashioned enterprise architect, which is, I don't see many people using it these days, but I didn't find anything better, to create this type of diagrams easily, so use that one. Another good concept to use in microservices is to employ something called health check. Health check is basically a few methods on your API which will return the status of the microservice. You can have different types of the health checks. The most common health check is so-called readiness health check and liveness health check. Readiness health check is some proper big check which goes through all the dependencies and will tell you, okay, I, as a service, I'm healthy, and all my dependencies are healthy as well. Very useful methods to invoke when you install your microservice and you want to see that everything is running. Another category of health check is so-called liveness health check. Liveness is some lightweight health check, which is supposed to be called quite regularly to find out if your microservice is still alive. And for example, Kubernetes can use the liveness health check to monitor your microservice. You can even configure Kubernetes to call this liveness health check regularly. And if the health check fails, you can instruct Kubernetes to restart your microservice in such case. Obviously, it must make sense. So, like, if you implement your liveness health check and you configure Kubernetes to restart your microservice, your health check must return error in such way that it express the way that if you restart me, I will be okay again. If it's some other internal error and Kubernetes is restarting your service all the time, it's not much help. But in certain scenarios, it might be good to use. And another important aspect of microservices architecture is monitoring and logging, because now you have many applications residing on different nodes, and you create, you make one request to your API, and that request results in request or service bus calls across different nodes of your application, and you want to find out what went wrong, if something went wrong. So you don't have a debugger anymore. You cannot debug the application in easy way anymore, because you can debug just one service, but you cannot debug, or you can, but it's quite complicated setup. So if you want to find out what's going on in your application, it's very useful to have some types of distributed monitoring and logging. Like, for example, in our application, we use application insights, which is like a monitoring and logging framework offered as a service on Azure. And what we have to implement in our application is you have to typically implement something called correlation ID. That's your job, which for example, the correlation ID. If you have a client and that client calls the backend, and at the time when it creates first web request, you create a correlation ID, and then you send this correlation ID to the other microservices participating in handling that request as well. It's typically a GUID. So then when you collect the log files from all the microservices, using that correlation ID, you can put all the things which happen related to that request together. And obviously you need some support to collect these logs, and the application insights is useful for this. Or if you use the Kubernetes on Azure, it can collect the logs for you as well, like from different pods. They have a monitoring service, and they have a query language you can use to collect the logs from different pods based on the query parameters you put into. So that was all in that short time I wanted to mention. Just a quick summary. Microservices address a lot of issues, which we can have in monolithic application, but they also introduce a lot of issues because in a certain aspect your life becomes easier, but in many other areas it will become more complicated. So when you thinking about microservices architecture on your project, you always have to think through all the issues you have. Is it good for me or not? And it's not a simple answer if it's good for you or not. There is no simple rule. It really depends on your project. Just as a general rule, I think I can say is that if your project is small and it's a relatively short time project, you wouldn't benefit with microservices, because it would be just like all the issues you're facing with inter-process communication I mentioned and the deployments and all things. It's not good for it. If you have a big project running for many years and your source code base, doesn't become manageable anymore, it's you see the issues I mentioned at the beginning. you can consider microservices, but then you have to be ready to handle other complexities I mentioned in this presentation.
Isn't better a rule of thumbs like to have? I don't think that the complexity of the project is, as you said, so important. Yeah, okay, since some complexity further, it's like no-brainer. Yeah, but you can hold still good complexity with good architecture, and if you do your work well. But I think the biggest like for enforcement of microservices is when you expect a heavy load.
Yeah,
Just my humble opinion. When you expect the really big load of your system, then it's like it's big enough. Otherwise, it would be just one microservice. Then it looks like it will be microservices.
No, definitely this is scenario. Yeah, if you have some small, relatively small application, but you face performance issues which will benefit from like quite rich deployment scenarios. It's definitely good to go this way as well. Actually, like for this type of scenario, it's I think quite good platform is Service Fabric, because you can employ Service Fabric in quite easy way on the small project as well, and it can bring you big performance benefit. They implement like various performance pattern. I forgot what are all day when I did the evaluation, but my impression was that if I need to quickly develop the small microservices architecture just because of the performance, I would probably go to the Service Fabric if I was .NET developer. But yeah, you're right. This can be a reason as well. Not just the organizational aspect of the microservices, but the performance aspect.
Yeah, I think it's a combination. That's my point. That since some complexity and some heavy load, if you want to just because of lowering complexity, I'm not sure if it's a good idea. If there is combination, heavy load and complexity, yeah, sure. But if it's just complex, the very huge complexity can still hold in very good order in big project to really big extent. And if you have, for example, some very strong aggregated root, one big, huge, then it's really hard to split it into microservices. So that's just my point is there is
that's another thing I didn't even mention it. Like we started with monolithic deployment, and one of the biggest challenges was okay, we in certain stage we still have to support the production. We are live, and we want to bit by bit we want to change the monolithic solution into the microservices, and it's quite a challenge. How you do it, and how you can develop new services and take bit by bit from monolith, and at the same time be in production all the time. So we solve part of it using the integration events, but it is quite complex. Yeah.
There is no. I think it's too big shortcut in just one sentence.
Yeah.
Just my opinion.
Yeah, so as I said, like, to tackle this complexity, use as many external tools you have. There is a lot of stuff which can help you to do the deployment right, and, don't implement your own service bus, use some implementation and things like that. That's obvious. I think if you want to start with microservices and you've never done it before, there is a lot of things to learn. And it's also good to learn from failures. There is quite a few presentations which are very interesting to see about the failed project in the microservices and wonder why they failed. This is just a couple of references. I have much more. Maybe I can compile them into something else. They would not just fit to the slide. If you want just to have an introduction what the microservices are, it's the first couple of links. This is quite good. If you have a Turan site, this is quite good introduction to the microservices. It's about 1.5 hours long or 2 hours long, and it will tell you many more things than I told you today. And on Polar side, it has quite detailed courses about microservices as well. This is the overview one, but there is 2 or 3 other one which are like 8 or 10 hours long. And if you in .NET world and you work with ASP.NET Core and Docker, this is really good. Well, it's a book or it's a set of patterns, and what is good is that it's kept up to date. It's developing all the time, and a lot of you will find in that book. You find a lot of general patterns which you should use in the microservices, and you find how you can implement these patterns in ASP.NET Node or in ASP.NET Core. So this is quite good book. It's a free book, and it's, as I said, it's updated. Every couple of months they add a new chapter to it. And yeah, this is quite interesting to see. This is the one I mentioned where the guys were developing microservices, and when they put it on, they waited for 10 minutes and nothing happened. So it's good, interesting to see as well. The only thing I didn't like here was, I mentioned it here, like, the consultant who comes to that conference, he say it didn't work because they developed the microservices in Microsoft way. And as a Microsoft way, he shown some block written by some Microsoft guy. So that block is not this guidance. So, if you see this first, this guy is not talking about the guidance I link here. He's talking about some block, which I don't know where he got it. So that's pretty much all I wanted to say. I mean, if you, if I don't know, does anyone work with the microservices here as well? Yeah, I would like to share the experience, or if you come with something,
Microservice support group. Like
No,
I do microservices.
No, I mean, like, it's good to know about the other people who do the same thing, and like, a lot of things we face. I'm sure you probably run into it before, or a lot of things I will face in future. Maybe you already faced. So, I would like to keep, I don't know, to create some mechanism how we can keep in touch. We can talk after about this. So yeah, so that's all I want to say. Do you have any questions? Okay, thank you for attention. I hope it was interesting for you.